Hello, this is Mustafa. In today's video, I would like to talk about networking based on TCP/IP model. Before I begin, I should tell you that I'm not an expert in networking. I am only interested in it because in embedded systems you encounter networking topics quite often. Recently, I started reading a book called Sam's Teach Yourself TCP/IP, and in this book, many of the networking subjects are explained beautifully. Therefore, in this video, I will just summarize what I learned about the TCP/IP model. As we all know, in a network, there are many entities such as routers, switches, and host computers, and these are interconnected with each other. Therefore, a host computer is able to access into the internet and, for example, to another server to get some information. And each of these entities, these host computers, routers, switches, and so on, or these servers, has a network stack. Network stack is also called TCP/IP software in the TCP/IP model. Therefore, we are going to investigate first what is inside these network stacks so that we can understand how network works. As you might already know, operating systems such as Linux are accompanied with powerful network stacks, and we call it also TCP/IP software. TCP/IP software is what I've shown you here, and in this we have many artifacts. So what we have network adapter drivers, we have protocol drivers, socket libraries, and in addition to that we have also some networking tools and services. So we have all these artifacts, and we have to categorize these artifacts in a way that it is easier to understand. So this is the TCP/IP software, and we divide it into 4 layers: application layer, transport layer, internet layer, and network access layer. There are of course more detailed models such as the OSI model, OSI model, and that divides into seven layers, but in the TCP/IP model we have only 4 layers. I think this is more understandable, therefore I will be focusing on the TCP/IP model. Also, what we have in a host or in a computer is we have some applications simply sending some message over the TCP/IP, so that eventually that information is converted to bit stream and it is carried out within the transmission medium. It can be either an Ethernet cable, air, or something else, and that information can be simply received by another device. So this is device number 2, and this is the device number 1, we can say. As I mentioned, we have 4 layers in this model, and each layer have a clear separation. Each layer send a message to the next one. So for example, in this application layer we have a message with a header. Header information contains the application layer header, right? And simply in each layer this message is appended. So first message is containing of a message and the application layer header, and in the transport layer header is appended. In the next layer, internet layer header is appended, and in the last layer, network access layer, a header related to network access layer is appended, and also some footer, so that the frame is constructed and then converted to the bit stream. The message coming out of application layer is simply called a message. In the transport layer it is called a segment. In the internet layer it is called a datagram, and in the network access layer it is called a frame. And this frame that is constructed is simply carried over using the transmission medium, and it is received first by the network access layer protocols, then the internet layer, then transport layer, and then the application layer. Okay, so let's start analyzing. So we have some application, and we want to go from layer to layer one by one, and eventually we will end up with the network access layer, right? So it is, I think, important to start with the network access layer, because in this layer basically we have everything related to the physical adapter. So this is the only layer related to the physical hardware. We have network adapters in our computers or embedded devices which have physical addresses. Using these physical addresses, data is converted into bit stream accessible by other drivers, other devices in the network, and only the destination will be processing the sent data. Our network adapter hardware could be different types of devices, such as Ethernet. It can be some Wi-Fi protocol. It can be Bluetooth, or it can be a modem, so a PPP modem. All of these examples are network devices. Therefore, there are protocols located in the network access layer related to the network adapter that we use. These you can think of some device drivers in kernel, and at the end a frame will be converted to a bit stream and sent it to the network, and will be received from another computer's network access layer. One layer above the network access layer, we have the internet layer. This is the layer that involves protocols such as IP, ICPMP, and ARP, Address Resolution Protocol. So IP protocol is the main one here. IP protocol is what assigns IP addresses to the data so that it can be addressed in a network. We cannot do this by using only physical address. We have to assign IP addresses so that it is accessible within a network. Therefore, IP protocol here is really important. There are, of course, some other protocols. There is ICMP protocol, which is used for pinging and diagnosing the network issues. And also there is address resolution protocol, which is used simply for finding physical addresses based on IP addresses. So if a physical address is unknown, simply an ARP broadcast can be made, and then the information, the physical device information will be received, and therefore in the TCP/IP software, ARP table will be updated, and we have IP address to MAC address, physical address mapping. One layer above the internet layer, we have the transport layer. Transport layer has mainly two protocols which are quite common. There are, of course, others, but TCP and UDP are mostly used. And main purpose of transport layer protocols such as TCP and UDP is to provide ability for multiple applications to talk with the network adapter using ports. So, for example, we can have one application that is using the port number 22, another application that is using the port number 23. So we have here basically a multiplexing mechanism so that many applications can access the network. Otherwise, only one application could be able to send a message. Here, difference between TCP and UDP is also quite known and simple. And in TCP, basically, data arrival is ensured Therefore, it is slower but reliable. It has some mechanisms to make sure that the data arrives. In UDP, there is no such mechanism. The data transmission or reception is not ensured. Therefore, UDP is fast but unreliable. So UDP is mainly used for video streaming and so on, because dropping one frame is not really much, but TCP is usually used for data that is required. So the final layer we have is the application layer above the transport layer. This is actually the most important layer to me, because most of the protocols that we know are potentially used in the application layer actually. So in this layer we have the ability to use predefined application layer protocols by making use of some application programming interfaces and some libraries basically. So we have many protocols, right? For email, for example, POP, IMAP, for file transmission, or simply secure shell, we have FTP and SSH. We have also ability to simply request a dynamic IP address using DHCP. We have ability to resolve domain names to IP addresses using the DNS. We have network time protocol, network file system protocol. We have the well-known HTTP and HTTPS secure protocols, and also we have TLS and SSL. So we have this many protocols, and we can make use of these protocols by using some APIs, right? We have, for example, the REST API to be able to use with HTTP. So this is what it translates to. We have the APIs here, right? And we have also the network tools. Network tools are also located in the application layer, we can say. In a Unix or Linux network, we have netstat, root, ifconfig, ping. For example, this ping is known to issue ICMP messages. So basically pinging and diagnosing the network, and this ping is using a raw socket, therefore transmitting a raw socket message, and then simply ICMP protocol in the internet layer is used. So it goes like this. But for example, let's imagine we have something else. We have developed an application, send some HTTP message using the TCP so that we can read the weather information. Therefore, it will go like so. So first the HTTP, then the TCP IP, because IP address will be assigned. Then we will go to the network access layer protocol so that we can, for example, request information from another weather server. Okay, so let's clear these out a bit. Okay, so we discussed about some networking tools and the ability to build custom applications based on APIs. We have also already created network services. We have web servers, name resolution servers, SSH, FTP servers, file and print servers. These are also using application layer protocols, whatever it may be. So it can be some UDP using a specific port, and then going to the IP, then to the network access layer. So as we discussed, in the transport layer we have some ports to be able to access from different applications. We have also well-known ports. So well-known ports are simply reserved port numbers. For example, just giving an example, I don't know the exact ones, but port numbers 20 and 21 I believe are reserved for the FTP. Therefore, if we have some FTP server here, it will be using these ports to be able to access. For example, port number I believe 22 is reserved for SSH protocol, so some SSH server located in this application layer will be using this 22 port. So simply put, the application in the application layer message will contain the actual application data, and in the transport layer some port information will be added. Of course, there are some flow and error checking mechanisms to mention here, but I'm just going really simple here. Some porting information, and in the internet layers some header containing the IP address information will be added, and in the network access layer some let's say physical address information will be added alongside with some bitstream checking flags. Okay, so that also being said, we can move on to the next one. As I said, each device on the network has TCP/IP software that consists of these 4 layers. So what kind of devices are there in a network? We have firewalls and routers. You can see here, and basically these are able to forward, filter and route packages based on routing tables and some algorithms. These routers are really important in networking, and also switches are quite important in order to be able to connect multiple hosts to a single network device. As you can see here, we use switches, and also we have some servers that are helping us in this networking journey. We have domain name servers, DNS servers, and we have DHCP servers. So in a typical modern day network scenario, a computer is assigned an IP address dynamically. Therefore, upon booting, it will simply request a dynamic IP address from a DHCP server. So it will go like this. It will ask for a dynamic IP address, then IP address will be sent and will be assigned in the internet layer of this host. And also, for example, when we are browsing the internet, we will often type in some domain names. Domain name is something like google.com, and IP address should be obtained from this domain name. And for that we have multiple DNS servers across the internet, and simply DNS using this DNS protocol, DNS server will be let's say requested to bring the IP information, because in these DNS servers there will be some tables with the IP address assignment to the domain names. Of course, there are nowadays really advanced advanced algorithms used. If the domain name couldn't be resolved, and then it will be forwarded to a more let's say related DNS server, and the IP address will be retrieved from that, and then information will come to the host computer again. Okay, so in this video we discussed mostly networking, really basic things. We have taken a special look at the TCP/IP model, and we have associated some of the protocols that we know to the messages that these layers deliver, and how basically network is interconnected and what happens in each layer, how the IP address is assigned, what is transport layer used for, what is application layer used for, and what is network access layer used for. So that being said, I think I can wrap up this video. If you like this video, please give it a thumbs up and subscribe to my channel. As I learn more, I will try to make more videos. So that's all for now.